run through a few things on this, and this has just really got one major topic in it. One thing about this book that I kind of like is it's got the top is usually one big topic in every section. Okay, like I'm teaching this trig online, there's like a million things in every section. Drives me crazy. So this is kind of helpful the way this is set up, I think. Okay, so what you're doing here, this is a quadratic inequality. It's already factored. You're looking at not where it's equal to 0, but you're looking at where it's greater than 0. And what that's going to mean graphically is where is it above the x-axis. Okay, so anytime you see that greater than, that's really what you're looking for graphically is on what interval is your parabola, which is what you're going to get, is that going to be above the x-axis. Okay, so here's how you do this algebraically. The first thing you do is it's nice if it's factored. So we actually just solve this equation, which we can do in our head. Forget the greater than, just set it equal to 0. Okay, so you're finding like a 0. So this would be x equals 3, and then that would be x equals -2. And then you're going to make what we call a sign chart. So what you want to do is go to the number line I gave you and just locate where x equals -2 and x equals 3. That's all you need to have on your number line is in order, -2 and 3. And then you divide this up into 2 intervals, or 3 intervals like that. There's 3 parts right there. Now what you're going to do is you're going to use test points like this. And these are the kind of sign charts that you'll do in calculus frequently. So watch carefully what I do if you've never done this. So what I do is I pick a number that's less than -2. And it doesn't matter what it is. I'm just going to call that -3. Okay, and then what I do is I plug into the original problem. So everywhere I see an x, you just replace with -3. So I've got -3 minus 3 times -3 plus 2. And all you care about is if it's negative or positive. That's all that makes any difference. So I don't even bother working this out. That's a negative number there. That's a negative number there. Yeah, it's -6 times -1, but who cares? What matters is it's positive. So no matter what test point you use, they're positive. And what that would mean is that would mean the graph is above the x-axis. What we just did is just showed that the y values are always positive when you're below -2. Okay, that's the idea. Now you take another test point. Now let's go between -2 and 3. And if you can use 0 because it's the easiest number to calculate with. Again, plug into the original, so you would have 0 minus 3, 0 plus 2. Okay, a lot of this stuff you kind of learn to do in your head. Well, that's a negative times a positive, so that's a negative. So what does that mean about the graph? It's below the x-axis. Okay, that's how that's going. So it's just picking a test point and computing. Okay, what's a good test point for the last one? 4. Keep it simple. You can do whatever you want to because it'll always give the same result. So now we just do 4 minus 3 times 4 plus 2. Okay, that's a positive times a positive. Therefore, it's a positive. So that means that you're above the x-axis. Okay, so that's what you've done there. You're always going to kind of take this approach is factor, get the zeros on your number line, and then analyze whether you're above or below the x-axis. Okay, so this problem is a greater than problem. So what are you looking for, above or below? Above. So here and here is where your answer lies. Okay, so what you would do, and you don't have to do this graph on the number line, but what this really means is it would be parenthesis 3 and then forever, parenthesis -2 and forever. Okay, and it's a parenthesis because that's a greater than. It doesn't have a greater than or equal to. So in interval notation, you would just say -infinity to -2, and that would be a parenthesis to exclude, and then it would be 3 to infinity. Okay, that's how that goes. Set builder, you just say set of x, and then you just say x is less than -2 or x is greater than 3. Okay, now graphically, I think you can do these problems graphically until you're right on these things, but you want to be able to do this both ways. Okay, does that make sense what I'm doing? Okay, so I'm doing test points just to analyze if the y's are positive or negative. And when we do the graph, I think that'll help you understand this a little bit better. So what we're going to do on this is just do the graph now. And you can do the graph on your calculator. I don't care if you do the graph on your calculator. So if we put this in, and I'm going to go ahead on this one and put it in the calculator, even though it's easy enough not to do it on the calculator. So what we want to do is just put in the original form. So I'm going to put in the factored form. There's no need to multiply it out. The calculator will do just fine. So x minus 3, x plus 2, and then do a standard window. So set your window back to standard. This is where I go zoom number 6. So zoom 6 puts you back in a standard window. You have a parabola opening up, and then this should answer. It should do the same thing the sign chart does. Now all I want you all to do is just a very rough graph. I want you have a 0 at 3. You have another 0 or x-intercept there, and it's good enough. That's all you have on that. It doesn't matter how accurate the rest of it is. So the idea is we were above in those two places. So you want to see that your sign chart just answers what the graph does anyway. So you're above there, and you're below there. Does that make sense? See, that's what that sign chart does, is it just tells you where that graph is above or below the x-axis. That's it. All right, is that logical to everyone? Okay, and that'll be kind of a fundamental thing in Calc 1 that you do all the time to help you figure out where things are increasing and decreasing, maxes and mins and stuff like that, okay, once you learn about a derivative. Okay, that's the standard. Now the next one is almost the same, so it's just got one other feature to it. Okay, so the first thing you want to do on this one is it's a less than or equal to problem. So you're going to be looking at where this one is below the x-axis. Okay, and we're going to do that same sign chart. What's the first thing you think you should do to this thing before you factor? Yeah, move the 12 over, then factor. Good. Okay, you got to get one side equal 0. So you would have x squared plus 7x plus 12 less than or equal to 0. And now you want to factor. Okay, so this one factors as x and x, and then you'll do 3 times 4 to get 12. Okay, that will be 2 plus signs like that. Okay, so be sure one side's set equal to 0 before you do the factoring. You always got to do that. Okay, so that means that you have x equals negative 3 and x equals negative 4. That just means on your graph, those are going to be your two x-intercepts, or negative 3 and negative 4. Okay, then be sure you put this in the right order. So there's negative 4, there's negative 3, and then again we just test into the factored form. I like to use the factored form because it's easier, it's less work. Okay, so what I'm going to do is, just like the last problem, we divide this up, and then we do test points like that. Okay, so let's see, for negative 4, I'm going to use like negative 5 as my test point. And then again, plug that into the factored form. So that would just give negative 5 plus 3 times negative 5 plus 4. And again, you don't have to work that out because that would be a negative times a negative. So that's a positive. Okay, and what that means is that means you are above the x-axis on that part of the graph. Okay. All right, and then we'll do one here. We got to use a decimal here. But don't freak out if you got to use a decimal. It's all going to be the same anyway. So I'm going to use negative 3.5. Okay, something that's in the middle. So if I plug this in, I would have negative 3.5 plus 3 times negative 3.5 plus 4. Okay, and remember, all you care about is whether these things are negative or positive. That first factor is negative. So negative 3.5 plus 3 is a negative. The second one is positive. So positive times negative is negative. So that means you're below. Okay. And then the last one, I'm going to use 0 because 0 is to the right of negative 3. So if I plug 0 in, I have 0 plus 3, 0 plus 4. Okay, that's a positive times a positive. So it goes like this. Now these signs don't necessarily always, there's situations where you could have the whole thing being positive. Or there's situations where you could have the whole thing being negative. That depends on how the parabola orients itself. All right, so I did those signs kind of quick, but again, you're plugging in test points and calculating. Are you with me there? The gist of what I'm doing, okay? Now, where is the answer? This is a less than or equal to problem, so where's the answer? This part right here, okay, where you're below. So, and you would have brackets on this, so the region where your graph is below the x-axis is right there. So your solution then we would say would be bracket -4, -3 bracket, and that again is because that's because it's that has a less than or equal to. As far as set builder goes, you would say set of x, then you'd say -4 less than or equal to x, less than or equal to -3, like that. Okay? And then graphically, you can put this in the calculator, but I'm not going to do that. I'm just going to show you what's going to happen on this problem anyway, because the sign chart tells you everything you need to know. So you basically would have two x-intercepts. The parabola opens upward because you have a positive x squared. So this graph is going to do something like that if you put it in your calculator. Okay? That's all that matters. Okay? And then these things, your graph doesn't even have to be all that accurate. You just want to have the basic shape. Okay? So the region that you were below was there. Okay? Any questions? Okay? All right? You want to be flexible about being able to do this both ways. And this section doesn't have much more in it. It's just learning how to do a quadratic inequality. We're going to learn how to do different types of inequalities. Okay, let's do a couple more. I want to show you just a few different cases that can happen. And with this one, we've already got one side equals 0, so we want to factor. So how do you factor x squared minus 3x? I ask that question because a lot of times students always want to do two parentheses every time they factor. What do? You take an x out, right? Don't forget, okay? I see it all the time. So you take an x out, and that would give you x times x minus 3 is less than 0. Okay, so then you can do this in your head. You get x equals 0, and you get x equals 3. So those are going to be the two places where it's going to cross the x-axis. Okay, so in your sign chart, you just locate x is 0, and then you locate x is 3, and then we'll go ahead and just do the test points, and then we'll see what we get. Okay? Okay, and again, I always like to, you can either plug your test points into the original or the factored. I find the factoring easier. That's why I do this. So I'm going to use a test point of -1. And again, I'm going to plug that into the factored form. So I'll have -1 times -1 minus 3. You can process that in your head if you want to. That's just a negative times a negative. So that's a positive. So that means that the graph, again, is above the x-axis. Okay. Test point between 0 and 3. Take your pick. I'm going to choose 1. Plug it in. You'll have 1 times 1 minus 3. Is that negative or positive? You can do the whole thing in your head. That's negative, right? Okay, that's a positive 1 times a negative 2. So that's a negative. So you're below the x-axis. Okay, and then finally from there, you take a point bigger than 3. Let's take like 4. And then we'd have 4 times 4 minus 3. So that's back to positive. Okay, so you'd have a positive times a positive is a positive, so you're above. Okay, you're going to find most of the time when you do these things, they're going to alternate. But not always. It doesn't have to be, because a parabola could always be above the x-axis, or it could always be below. That happens. Okay, it depends on the situation. Okay, so what are you looking for on this problem? Where it's below or where it's above? Where it's below, okay, because it's less than. So that means you're here. Are you going to use parentheses or brackets on your interval? Parentheses, right, yeah, parentheses, because it has a less than. It doesn't have a less than or equal to. So it's just going to be between 0 and 3. So that would be your interval answer. And then set builder, you just say set of x. And then the way you write this is you have to say 0 less than x less than 3 That's how you put that x in the middle of 0 and 3 with two less than signs is the way to do that. Okay. Graphically on this one, this is what you would expect to find. So let's see, we have, now this is good enough. You're just going to draw a real quick sketch on this. We have x-intercept at 0, 1 at 3, and then the parabola opens upward. So if you put that in your graphing calculator, that's what you would find. And what you're looking for again is that region where it's below the x-axis. That's it. Okay? Is that good? Okay. All right. See, factoring kind of shows up all the time when you're working with quadratic functions. Okay, so I think I'm going to go ahead and just do this next problem, and then I'll kind of summarize what you need to have before Wednesday's test, and then these applications we'll just do next week. So this one, what's the first thing you do on example 4? Got to move the 6x, right? Get one side equals 0. So I'm going to just kind of do this over at the side here. I'll just do it right here. So we have 4x squared minus 6x plus 9. Now you could either try to factor that or go to the quadratic formula. I'm not sure if this factors or not, but I'm going to try it. So if I do this, I would have, for 4x, I could use 2x and 2x. For 9, I could do 3 and 3. But that would be a 6x, that would be a 6x. So there's no way to make that work out. I'm pretty sure this one does not factor. Okay, I think, so if it doesn't factor, then what I would do is I'd just go immediately to my graphing calculator, but I'll kind of show you what happens. If you went to the quadratic formula on this, you could also get your zeros that way. Now I'm going to do that just kind of at the side here. You don't have to write this down necessarily, but I want to show you what the quadratic formula do. So b is -6. You can write this down if you feel like you need to write down quadratic formula. B is, so you'd have b squared, and then 4 times a times c, all over 2 times a, like that. Now what's going to matter on this problem is this thing right here. What's under the radical? That's what's going to matter, and that's what I mainly want to show you on this, is you'd have 6 plus or minus, well, let's see, that would be, and I'm just going to do this in one step on my calculator here. I'm just going to do 36, and then that would be minus, I'm pretty sure that's 144. It'd be 4 times 4 times 9. You're going to get a negative number. That's the main thing I want you to see. So that gives -108 over 8 like that. Okay, what does that tell you about your zeros if there's a negative under there? It means you don't have one, right? Okay, so this really means that there are no x-intercepts because they're complex numbers. So is it possible for a parabola to never intercept the x-axis? Yeah, it could be shifted up or turning down and shifting down. That's what you're going to find on here. So what you're going to find on here basically is when you graph this, that it's always going to be positive. So I'm going to put this in the graphing calculator and just put this like this. So I'm going to put in the form after we move the 6x. So we just have 4x squared and then minus 6x and then plus 9. Now see, the parabola is opening upward, and because the quadratic formula gave me a negative number in the radical, I know the graph is above the x-axis, the whole thing. So if I just do a zoom 6, I think that's what you're going to find, see? All right? So it's always positive. So what you'd find on this is y is always positive. Therefore, the solution would be, there is no solution. Now, see, this is less than 0. So less than would be below the x-axis. Well, it's never below the x-axis. So that means there's no solution. Okay, so you just write it that way. You just write it in words. Set builder, you can just do empty set symbol like that. Okay, so graphically, that's what you'd kind of have to see on this. And you don't have to draw a very accurate graph. I don't care. I mean, it's just if you draw a picture like that, that's good enough. Okay, so sometimes that will happen on a quadratic. Now, what would you say the answer would be? What if it was greater than instead of less than? Then what would the answer be? All real numbers, exactly. Okay, so in this case, it's never below the x-axis, so it's no solution. So that's it. Okay, does that make any sense? Okay. Okay, so just kind of